Hello, I'm Andrew Lawlor, and this is my presentation about improved sales territory management. As an introduction, Salesforce is a popular customer relationship management platform that tracks Salesforce automation data. Customers and prospects are usually assigned to a geographic territory owned by one sales rep. Enterprise sales teams must establish territory boundaries annually in a painful manual process, where a primary constraint when forming these territories is geographic proximity, but this is not enough. The best territories balance a variety of business constraints. This project proposes to use machine learning algorithms to automate the manual error-prone process of identifying optimal sales territories. Data set I will use will come from the commercial real estate industry in which I work. There's 71,000 properties geocoded with latitude and longitude, and I'll focus on the lower 48 states for visual efficiency and impact. As an evaluation metric, I will look at the territories to see if they are geographically sensible, and do they identify territories that balance a variety of business metrics, for example, the number of customers balanced between the territories, and is revenue balanced among those territories as well. And ultimately, would a real-world enterprise implement these territories in practice? We will split the data set into training and test, where the training data set will be used to set the centroids of the territories, and then the test data set will be used to work with customers as they come into and out of the territories as they were defined during the annual process. And this dovetails very well with how organizations do their territories. They set their territories up in the beginning of their fiscal year. That corresponds to the training data set. And then the test data set would be analogous to additional prospects and customers entering those territories. And well-defined territories will work well with unseen prospects and customers. Our baseline uses the k-means algorithm. We use k equals 50 for 50 territories, which is pretty common among enterprise sales teams in the US. We measure the total cost of these found territories using a variety of measures. With inertia, which is unique to k-means, we see that the full data set has a higher cost, as we would expect, when compared to the training data set, as the centroids and territories definitions do not change once they are trained. So we get a higher cost when looking at the full data set. There are three other measures by which we can calculate the total cost of territories, including the Silhouette, the Davies Bolden, and the Kalinsky Harabaz. And we see here that the k-means territories are stable and with no signs of overfitting. Here's a graphical representation of the k-means clusters. You see they are roughly of equal size, and the nature of k-means is that the territories, the clusters, are going to be spherical in nature, and that's reflected here. Next, for our main approach, we use spectral clustering. The advantage of spectral clustering is that the clusters, territories, do not have to be spherical, so it can find territories that match the data better, including population and geographic features of the data. We use the nearest neighbors affinity to keep the computations down via a sparse data set. And we see here again with the different cost measures that these spectral clusters do have, they're less compact and less well separated, but that's to be expected because they're finding more natural beneficial clusters and territories. Here's a graphical representation of the territories as found with spectral clusters. You can see these are no longer of equal size. It's identifying population centers and geographic boundaries, and it's creating territories for those regions. And we can look here side by side, again, seeing the benefit of spectral clustering, finding population centers in LA, Bay Area, Florida, Mid-Atlantic, and Northeastern regions. And on this diagram, you can see with the boundaries highlighted even further, it pops out at you how the algorithm is automatically able to find these population centers and geographic features that make for more natural territories. So as a result, we see that although the territories from k-means have better scores than the spectral clustering scores, they don't fit as well in the real world. K-means ignores population dense areas, resulting in territories that are unbalanced in customer count and not as beneficial in real world. Error analysis, we looked at misalignment between internal metrics and business objectives between the two algorithms, and we noted that k-means really failed around populated metropolitan areas. For our future work in the Oracle, I would want to add additional constraints to our fitting algorithm to balance not only on geographic features, but also on total revenue, number of clients, average customer size, the industry, and in a variety of other measures. And when you add these additional attributes to this problem, it turns the problem into a constraint satisfaction problem, which can be significantly more complex to solve, but it would be fun to develop that solution and find even more business friendly territories that customers could use and benefit from automation. I believe that I was successful in building this, that it could lead to a commercially successful product on Salesforce's App Exchange. And I look forward to doing that in another context. Thank you for tuning in today. Hope you enjoyed my project.